All right, so this video is just about inequalities in general now. So we've done polynomials, we've done rationals, we've done radicals, and so now we're going to put it all together and just give you a graphing calculator version of this. So our first one is already set up for us. So what we have here is an equal to, greater than, and then less than. So we're going to take this and plug this in our calculator. We're going to find out when is it equal, when is it greater than, and when is it less than. And we're going to do this with Desmos first. So this is a leading term that's positive. So you already know your graph will look like this. So what you have to do is first find out, number one, when does it equal 0? So this is when it equals 0. This is when it equals 0. You need to find those numbers. So we take this, we plug it in our calculator, and it gives us this. So if I click on that one, I get negative 0.667 and 0.6. These are the answers that I get. So you can change that to a fraction if you want. That's negative 2/3, and that's positive 3/5, or we can just leave them as a decimals, which is what we're going to do. So that is when it equals 0. You can see it at negative 0.667 we get 0, and at 0.6 we get 0. So we have negative 0.667 and 0.6. So our answers here are x equals negative 0.667 and x equals 0.6. Let's move those down to the bottom. Down here, and we put a. So that's our solution set for this. Like I said, you could say negative 2/3, and that would be 3/5 if you want as well. But those are your answers. So now we move on to the next one, greater than. Greater than is greater. It's when our graph is greater. So it's this region here. So we're just using the picture of the graph to figure out what the solution is. So that's greater. And that is greater right in here. So the regions for our greater than would be negative infinity to negative 0.667 parenthesis union 0.6 comma infinity. I can shrink that down so we have more room in here. So that would be B. And then now less than. Less than is below. So right here, this is when our graph is less than. We have everything equal to 0 here. So by having this as 0, we can know when does it equal 0, and when is it bigger than 0, and when is it less than 0. So the last one says less than or equal to. So when we write this answer, C, we want to put bracket negative 0.667 comma 0.6 bracket. So that's all you're doing on each graph is you're just looking at it and deciding when is it greater than and when is it less than. And it all depends on those zeros. Plugging this in our TI-85 calculator would give us this as well. And so we just need those 2 points. So I've already drawn the y equals line so that we can use the intersect. You could also use the 0 function. But hitting enter, 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 it gives us our first, which is 0.6. And then we do it again. Enter, enter. And then this time we want it closer to the other side. Enter. And negative 0.66. So 0.67. So that is our region where it's equal. Here and here, it's greater here and less down here. So you can see that that's less. All right, let's try another one. So it doesn't matter what function we're dealing with. We have a rational here and we have a radical here. What we want to first do is set this equal to 0. So what that means is to just bring everything over to one side like this. And then now we have 0, and we do that for each of them. So this would really be 5x plus 2 over 2x minus 6 minus 2 is less than 0. And the last one is 5x plus 2 over 2x minus 6 minus 2 is greater than or equal to 0. Let's get this one out of the way here. Move it up there. There we go. So these are the equations you want to do with. If we have it equal to 0, then we know when it's crossing the x-axis, we can easily find those points. So we set it equal to 0. Or less than or greater than. All right. The one thing that's different now is we have domain restrictions. So you do want to write your domain here. And our domain here is x cannot be 3. So if you were to solve 2x minus 6, this was from 2x minus 6 cannot be 0, you would get x cannot be 3. And you do have to put that on your graph now. That is going to be an important point. So we already know that this is a vertical asymptote. which means 3 is not part of the function. But what it does do is break up our graph. So now if we look at the Desmos graph from that, we get this. And again, you just click on the graphs. It tells you the points. You can click on them. It's giving me a lot now. Look at that. So we're going from -14 and then 3. Remember, 3 was our issue. That's our vertical asymptote here. So if I get rid of this, you'll see it on the graph. We have a vertical asymptote right here. That is where it breaks the graph. So you can see it actually went from less than, and then on the other side of this line, it is now greater than. So you need to include those points. And so we're going to put a dot at x equals 14. 14 is when it equals 0. 3 does not equal 0. It's giving me that 0.30, but it's not actually there. See, if I get rid of it, now all I can find is that one. It's giving me the line because of those two lines intersecting from my shading. But only -14 is a 0. So only -14 is our answer. So x equals -14. And you can check this. If you were to plug -14 into this first equation, it would come out to 2. If you plug -14 in here, it would also come out to 2. And then subtracting 2 would give you 0. So we can now come over here and we put our special dot on there, which is -14. And then we go back and look at our graph. And so we're going to trace this line. You can see it here and here. All right, trace that graph. So that's what we're looking at right now. That's what we're going to put on our graph. So it does this, and be very exaggerated when you do it like that. And then the other one's up here. And we know it's not going to cross because there's no zeros here. You can see that there are no zeros. Okay, so now back to our graph. So here is where it's greater than. The blue regions are greater than. And the red is when it's less. So we're going to be going from -infinity to -14. That's one region. And then also from 3 to infinity. But from -infinity to -14, this is a bracket if it's equal to it. But this will always be a parenthesis because this value is undefined here. And then when we do our less than, this is here, our less than will go from -14 to that value of 3. So our less than is our middle one. We know that that was this region here. This is our less than. So our answer for part B would be, since it's -14, 3, this is because it's just plain old less than. All right, and then now on to C. C is our greater than. So that's this region. This region is above. And this region is above. And so our greater than is from -infinity to -14, but it is equal to it, so we put a bracket. We have greater than or equal to, so that's a bracket. Union. And then the last part is from 3 to infinity. And like I said, this is undefined. So undefineds will always be parentheses when you graph them, but this is all you're doing on each one. You're going to throw it in a calculator, see when it equals 0, also include the domain, and from here to here and from here to here. If you're going to do this by hand, you would have to solve this and then sit here and plug in your graph, figure out how it looks, plug in values in between each. Okay, let's try another. This guy right here. So we know our domain here is the first one is 2x minus 3 must be greater than or equal to 0, and also x plus 7 must be greater than or equal to 0. So if we solve this, we get x is greater than or equal to 3/2, and x is greater than or equal to -7. So if you remember our AND statements, what's happening is this is an AND statement. So we want to know when is this one greater than 3/2 or equal to 3/2 and greater than or equal to -7. So we need to put them on a graph and look at them. So that's 3/2. And so -7 would be back here. They're both greater than. So we want to know when is it good for both. And so that's here. This region is when we can plug numbers in. And the reason we need both is these numbers both need to be plugged into this function and be able to come out real. So if I were to plug -7 into the first one, I would get -14 minus 3 is -17. That would come out imaginary. All of these numbers in this region will come out imaginary. All of these will come out real for both. That's the key. So our domain here is from 3/2 to infinity. And so when we plug this in our calculator, remember we still have to make this equal to 0. Minus 2 equals 0. And then we do that for all of them. Okay, so the middle one's less, the other one's great. So these are going to be the red, these are going to be the blue. If we were to solve this equation, it would come out to say some x value, right? But it's not going to be only solutions that will come out true as for here. Okay, so now if we look at our graph, you can see that this is our graph that we have right here. And I've got that starting point sitting right there. So to get rid of it, you can see it now starts. So where does it start at? It starts at 3/2. That's the 1.5. There's nothing over here that graphs. So if I go over here, there's nothing there. So this is our graph. And so if we click on it, you'll see 42 was our solution. So our x here for part A is x equals 42. That's what we get for our graph, 42. So now we just draw it on here. We put a dot, put 42 there, and we draw our graph. But again, we have to put our domain. So our domain starts at 3/2. We know that this is included. So I like to put a little bracket there to just kind of remind myself. And so we know this is greater than. And we know this is our less than answer. And so the only one that gets the bracket is that guy right here, the 42. With respect to the inequality. So the inequality only belongs to the equal 0. So it equals 0 at 42. So that's the only time we can use that. So for less than, part B, we know it's from 3/2, comma, 42, bracket. So it's a bracket because it's less than or equal to. This is always a bracket because it comes from our domain. 3/2, comma, infinity. So you see the bracket sitting right there. This right here is what we use here. So it's already got a bracket. We're just attaching it again. All right, and then part C is the other part. So it's our greater than. And so that would then be bracket 42, comma, infinity. And again, it's a bracket because it's greater than or equal to. It's got the equal sign on there. And that's it. So on each one, you're just looking at the pictures, at the graphs they make. And you can go to my website, just type in Ian McCants. You'll see the Google site pop up and you can find these inequalities. So you can plug in any function you want in there. Just like this, you just change the function and it will graph it for you. You'll have the blue, so anything that's blue is greater than, anything that's red is less than, and wherever it hits the x-axis, that's 0. Just make sure you know your domains, because if you put 3 as a solution, it's going to come out wrong for that one. And our last one, this is it. So we know our solution's 42, this is the less than, this is the greater than, and that's it. Thank you.